Writing equations. So using the given information, we can write an equation to model the data for a given line. And our goal is to get the equation into slope-intercept form, that y equals mx plus b. Let's write that in here. That's the one we're always trying to eventually get to here. And then given information, that's probably good for you to have in your notes. That way you know where to start. If you have the slope, if you have the y-intercept, go straight to slope-intercept form. If you have the slope and a point that's not the y-intercept, you'll want to go to point-slope form, that y minus y1 equals m times x minus x1. If you're given 2 points, you can also do point-slope form. And if you have a graph, you can do either one. And we're going to go through each of those right now. As an example, most of this video is just going through a few examples. Example 1. Write equation for the line through 0.09 with a slope of 4/7. Great. Right away, if I'm thinking about y equals mx plus b, where m equals my slope, I can see that I already have my slope. Let's pick a different color here. There we go. So my m right away is 4/7. That's already done. And if I have 0,9 where x equals 0, I know my y-intercept. So I know b equals positive 9. I can plug that back into my original equation. Y equals 4/7 x plus 9. Not too bad. There we go. If we have our y-intercept and we have our slope, we can toss that right into the line, plug it in, and we're good to go. But what if you don't have your y-intercept? All right, let's take a look and see what we should do here. Do I have my m? Yes, I do. Slope of 6/5. Do I have a y-intercept? No, but I do have a given point. That means I can do my point-slope form. I have my slope, m equals 6/5, and I have a point, my x1 is -3, and my y1 is 5. x1 here, y1 here, which means I can solve in point-slope form, or I can write an equation in point-slope form. Y minus 5 equals 6/5 times x minus -3. If I have x minus -3, I can translate that to x plus 3. Make it a little bit easier to distribute. I'm going to keep y minus 5 for now, trying to get to slope-intercept form. 6/5 times x, and then I'm going to distribute here, plus 6 times 3/1 is 18/5, and I can keep that like that. That's fine. I want to add 5 to both sides. If I'm adding 5 to both sides, let's see here, I have 18/5 plus 5/1. I could multiply that by both sides by 5 to keep the denominators the same. 5 times 5 is 25. 18 plus 25 is 43/5. This cancels out. My slope-intercept form, y equals 6/5 x plus 43/5. Couple steps there, but in the end, we end up with our slope-intercept form, and we are done with this problem. No need to give me decimals or anything outside of an improper fraction like this. This would be satisfactory to me. If you can simplify, that'd be great, but 43 and 5, that's going to be it. Example 3 here, we don't know our slope, but we are given 2 points, which means that we can find our slope. Remember that our slope equals our change in y2 minus y1 over x2 minus x1. Remember that rise over run, that change in y over change in x. It's going to help us find our slope. So for here, I can do 8 minus negative 3 over, I'm getting those numbers from right here, 7 minus negative 4. Special case here, so I add the opposite. Oh, that's going to work out really nice. 11 over 11, so my slope is 1. Oh, that's great. Love when the slope is 1. Now with my slope being 1, I'm able to plug this into point slope form, and I'm actually going to show you for both here so that you can see that they actually work out the same. We have y minus, and let's do this one first. My y1 is negative 3 equals, my slope is 1, and then x minus negative 4. X minus negative 4. We end up with, we translate this, y plus 3, and this is going to be x plus 4. I also can distribute the 1, but I think it's safe to say that that's going to remain as x plus 4. Subtract 3 from both sides. Y equals x plus 1. Awesome. I have my equation in slope-intercept form. I found my slope, plugged it into point slope form, and then translated it from there. Let's do the other one to check and see if it still works. Point slope form, this is y minus 8 equals 1 times x minus 7. We keep the y minus 8. We distribute the 1, which doesn't change anything. X minus 7 remains. I'm going to add 8 to both sides. Y is going to equal, cancel that out, x negative 7 plus 8 is 1. Yay! That's the same thing. Now what about a graph? Writing an equation in slope-intercept form for the line and then just a picture of a graph. Well, it'd be nice if we knew our slope. It'd be nice if we were given other information, but we're not. We can see right away, there is one nice hint here. It won't always happen. But our y-intercept is pretty clear. When x equals 0, our y is negative 3. So we have a point and its slope-intercept form for the y-intercept. If we could find another point and figure out our slope, that might help us get straight to slope-intercept form. Remember that m is our rise over run. Okay, so we can kind of guesstimate here. If we find another point, looks like there's a point on a line, there's a point. Let's use this one here. 1, negative 1 as our other point, 1, negative 1. There's lots of options we could do here, but I'm going to choose to find the slope first. So y2 minus y1, so this is going to be negative 1 minus negative 3 over 1 minus 0. Always love it when I have 1 minus 0. Did I do that right? Yeah, I did. This equals here, negative 1 plus 3 is going to be 2 over 1 minus 0 is 1, so my slope is 2. If I have m and if I have my y-intercept, remember my y-intercept, whenever x equals 0, what is my y point? I can go straight into slope-intercept form, which would be y equals 2x minus 3. If you're given two other points, if you don't have your y-intercept, you can still do all the things we've done before, but we're going to take those points and translate them into an equation. All right? Head to your Schoology page and try the problem on there.